All right, now we're talking about calorimetry. And from the first law, we know that du is equal to dq plus dw exp plus dwe. And we're saying that dw exp is just expansion work and dwe is extra work, and the q stands for heat, whereas u is for internal energy. So at constant volume, with the system incapable of doing any other work, we have that du is equal to dq in infinitesimal form. Or we can write delta u is equal to q with the subscript v, denoting that this process takes place at constant volume. So when we write the delta, we're just signifying that this can be measured, whereas du is an infinitesimal, so there's a slight distinction there. And to recap, we said du is equal to dq plus these other terms for work, but we're saying that this system is incapable of doing any work. So we're taking out the terms for work, so that gives us at constant volume that the change in internal energy is equal to the heat supplied. And our topic overall, calorimetry, is the study of heat transfer during a physical or chemical process. So we can say that the most common device for measuring delta U is an adiabatic bomb calorimeter. So what does adiabatic mean? Adiabatic process is a process that does not permit the transfer of energy in the form of heat. So it doesn't permit the transfer of energy as heat. And a calorimeter is a device for measuring energy transferred as heat. Okay, so when you're doing these bomb calorimeter problems or adiabatic bomb calorimeter problems, we have that Q is equal to some calorimeter constant C, which is determined experimentally, and it's C multiplied by delta T, or the change in temperature. So we can summarize that by saying that when you're doing calorimetry, the change in temperature is proportional to the energy that the reaction releases or absorbs as heat. So you'll have a chemical reaction going on in this bomb calorimeter, and however much energy is released or absorbed, you'll get a change in temperature, and you're going to be doing an experiment to determine that.